My name is Austin Finley, and I'm an Associate Technical Product Manager for the Electrolytics group at KEMET. So first things is I just want to show a snapshot of what the portfolio for the Electrolytics business group looks like. We have axials, snap-ins, press fits, screw terminals, basically all of your standard wet electrolyte aluminum capacitors. We also have varistors and relays in our group, but like Sam said, today our topic is the conductive polymer and the SMD and radial. So solid polymer aluminum capacitors can be used in a wide variety of industries and applications, similar to what you see your current wet electrolytic capacitors being used for today. The main features, though, of the solid polymer are that we have both form factors with radial or leaded and surface mount. They are able to handle a much higher ripple current. They have a longer, more predictable life compared to the wet electrolytics with the stable characteristics. They have a low impedance and are halogen free. Now, KEMET's specific solid polymer products, we offer capacitances up to 2,700 microfarads. We have voltages up to 250 volts, which is the highest in the solid polymer market currently for aluminum capacitors. The temperature ranges are from your minus 55C range, which is very popular with our aerospace applications, to 125C. And life, we offer up to 5,000 hours rated. Digging further into the solid polymer aluminum applications, really like to focus on the DC applications that have a higher AC ripple. I'm not going to read all of these off. Everyone here can read this, but you can see that we have a myriad of applications underneath automotive, inside computers, into telecommunications, industrial, and gaming. And for your Japanese gaming aficionados, we also are in pachinko. So to show you a block diagram of just the basic differences between a standard aluminum electrolytic capacitor and a solid polymer aluminum capacitor, you can see that there's your anode foil followed by an oxide layer, and then there is the electrolyte. On the left of the screen, you can see that it's typically a wet electrolyte, whereas the solid polymer aluminum has solid polymer there, then followed by the separator paper. Then again, there's another layer of polymer, followed by an oxide layer, then followed by your cathode foil. A breakdown of your A75 and A76 construction, you can see that there is a wound element inside of aluminum can, and it goes paper spacer, which is impregnated with your solid polymer, followed by your anode aluminum foil, followed by another paper spacer that's been impregnated with solid polymer, followed by your cathode aluminum foil. And then your leads go through this rubbered seal to attach to two terminal tabs, and that is all crimped together. So why choose polymers? Compared to your standard electrolytic capacitors, there's less heat generated during operations. The polymer is a much more conductive cathode system than the standard electrolytics, which offers a much lower ESR and gives you much higher ripple current capability. Across frequencies and temperatures, it's better stability with longer life. There's no concern about electrolyte leakage coming from the part due to the fact there is no wet electrolyte, it's all solid polymer. And there's no fear of ignition. So digging deeper into the advantages of polymers, you can see in the graphs on the right, as the part is being used throughout its lifespan, with your standard wet electrolytics, which is an orange and the gray line here, eventually you're going to run out of electrolyte and you're going to lose that surface area contact, which is going to cause your capacitance to drop. With the solid polymer, there's going to be some Mild oxidation, you may lose a little cap over time, but nothing compared to the wet electrolytics. Along with that surface disconnection, you're also going to see a large spike in your ESR for the wet electrolytics, again, the gray and orange lines. Speaking of life, the solid polymer aluminum, for every 20 degrees C drop in temperature, the life increases by a factor of 10, compared to the wet electrolyte capacitors, which every 20 degrees C drop in temperature, their life only increases by a factor of 4. Now, currently, this is only true up to 105C. KEMET is currently investigating using our 125C parts at 105C to see what kind of benefits there are. Aluminum polymer capacitors offer a very low ESR versus traditional aluminum electrolytic capacitors. It is often possible to replace several electrolytic caps with one polymer cap, reducing the number of components and maximizing the board space. This graph shows that the ESR of the polymer cap is nearly constant. There is a slight deviation of 233 milliohms across the temperature range, while the ESR of the electrolytic cap has a change of 254 ohms. Due to the conductive polymer, the curve of the solid polymer aluminum capacitor, ESR is significantly lower than that of a standard electrolytic capacitor. In most cases, the impedance of the solid polymer aluminum electrolytic capacitor is an order of magnitude less than the aluminum electrolytic capacitor. Also, you can see that the ESR values across frequencies are much more stable for the solid polymer aluminum compared to the aluminum electrolytic. The highly conductive polymer of the solid polymer aluminum capacitor results in a lower ESR than traditional aluminum electrolytic capacitors. Lower ESR allows aluminum polymer capacitors to withstand significantly higher ripple currents during normal operation than other electrolytic capacitors. Now here we have a breakdown of the solid polymer series, aluminum solid polymer series that KEMET offers. Our A75 ranges are all radials. The A750 is kind of our baseline radial for solid polymer, which goes up to 63 volts and has 2,000 hours of rated life at 105C. The A755 is our longer life radial part, which goes up to 5,000 hours. Our A758 is the miniaturized version of the A755, so it's still the 5,000 hour life, but it's much smaller components. And then the A759 is not only our highest voltage part, along with the highest voltage on the market, it's also our high temperature part. So this part is rated up to 125C, and we offer up to 250 volts. With the A76 series, this is our SMD. The A765 is our lower voltage baseline, going from 2.5 volts to 25 volts DC with a rated life of 2,000 hours. The A767 is the higher voltage version of that, with voltages from 35 to 100 volts, also 2,000 hour rated life. Our A766 is our longer life series, going up to 5,000 hours at 105C. And then the A768 is our high temperature series for the SMD, going up to 125C and 2,000 hours rated life. Now, when it comes to figuring out what part number you want, here's an example of how you read your polymer part number from KEMET. A is your capacitor class, A being aluminum. 750 is one of the series. We just went through all of those series. The size code, each data sheet will have a 2-letter combination showing the dimension table. The next 3 digits are your capacitance code in picofarads, with the first 2 digits representing significant figures of the capacitance values, and the last digit specifies the number of zeros. Next character is your tolerance, which is an M, which is plus or minus 20% capacitance tolerance. The next 2 letter combinations would be your rated voltage. It's a number followed by a letter. And with the A750, we have anything from 2.5 to 63. The next 2 letters are your packaging, which again can be found in our data sheets. The next one is the electrical parameters. So there are 2 options. There are E for the standard ESR, and then S is for automotive. And with that, the AEC-Q200 is available on parts 25 volts or greater upon request, and I will cover more of that in a couple of more slides. Then your last 3 digits represent the significant figures for your ESR in milliohms. Now this table shows the comparison of aluminum electrolytic capacitors. It's your traditional electrolytic versus your solid polymer, and then also I'm going to show a hybrid in there just for reference. With the price, you're not going to beat a standard wet electrolytic. There's no way to make it cheaper than that. So that is going to have your best price, then your solid polymer, followed by your hybrid. With your frequency characteristics, however, like we highlighted earlier, the solid polymer aluminum really shines. With the temperature range, the traditional electrolytic can go up to very high temperatures for shorter periods of life, whereas the solid polymer is currently limited to the 125C range. However, with the temperature characteristics, the solid polymer behaves much better at the extremes of its temperature range compared to the standard wet electrolytic. Ripple current, again, that's another highlighting where the solid polymer aluminum shines. Leakage current, due to the ESR being so low on these solid polymers, they're not as good for leakage current compared to a traditional wet electrolytic or a hybrid aluminum. With life, this is kind of a baseline of calling it an 85C application range, and if you derate that, the solid polymer aluminum, like we talked about before, increases by a factor of 10, whereas the traditional electrolytic only increases by a factor of 4. Again, solid polymer, due to the stable characteristics, are very good in high reliability applications, and they all have the potential to be qualified for AEC-Q200. And I also just want to highlight with the hybrid aluminum, if you just kind of notice that it all kind of sits in the middle of the road between the solid polymer aluminum and the wet electrolytic, being that it's a combination of both worlds. It's never going to be the best really at anything, but it's going to be kind of in the middle and maybe not have as high strengths as the other 2, but it will also not have the weaknesses of the other 2. So what is next for KEMET? AEC-Q200 qualification, like I was talking about before. With the solid polymer, it is now available on the A768 series, which is our high temperature SMD series, less than or equal to 63 volts. It's also available on request for greater than or equal to 25 volts by part number on the other series. And then the next plan for us is to target more families via each series. We got hybrids coming next, and when those come out, we are targeting on all series being AEC-Q200 qualified. Anti-vibration, so we're really trying to ramp up the amount of vibration that these solid polymers can handle going forward. SMD and radial hybrids, we plan on releasing these later this year. And that's all I have. Thank you again for allowing me to present. And if you want, here's my contact information if you'd like to jot that down.